Hi, this will be a video for the final milestone, the animation system. And right now I'm on the converter section, and I will be building this under the release mode. And for some linkers problems, and the release mode has much less warnings compared to debug. So I'm gonna use this one, and I'll try to fix this bug later. Not sure where this come from. Maybe it's coming from the mass library and has some conflicts with others. Anyway, so we just built the FBX converter, and I'll be copying this over to this site for my command lines. And so my FBX format will be pretty much the same as always. It's all stored under the models package, the animation, the vertices, and everything. For this case, we'll be demonstrating converting the teddy bear, because the humanoid conversion takes so long, and I'll make this demo a little shorter. Teddy TJA FBX into Teddy TGA. I'll delete this one too. .s. This is my extension of choice. S model. And yeah, I'll convert it. This will include all the vertices, normals, UV coordinates, and the animations and skeleton hierarchy. And we got it. Now we'll be going to our rendering framework, which I call the render framework projects, and I'll be copying over this one. So for this projects, my rendering, this is my engines, and under to load the models is the same as before, and for the animation section we will be demonstrating how the animation works. So I import from the Teddy DGA S model. Anyway, I'm gonna show the demo first, and then I'll go over the code. There's a bunch of warnings for the time being. Right, the teddy bears skeletons is this two. This is the idle animations. This is the walking bear animation. And these two who are fighting is this is punch animation. This is shoot animation. And in order for this choreograph to work, I kind of offset, because animation has different frame counts, and I think one has 270 and the other one has 270 something. So I make the speed modifier slightly different so they can match the frame count, and kind of offset their frame and to play together. Seems like one punching the others. For this animation, the red skeleton, and if I press T, it will change the animations. Press T again. If I press Y, it will stop at that frame. Same goes to in other animations. It will play and stop, play and stop. And this is the playing backwards. I didn't really set up a lot of keyboard inputs because it's gonna be making this confusing, so I only demonstrate them as skeleton, and then later I will showcase the code to show you that these are actually animation controllers which are separate to each other. And these are two humans running in different frame offsets. Just showcase for that. And the let's see, play, pause, forward, backwards, fast, slow. Um, yeah, fast, slow. Well, I'm not sure if this count, but like these two are actually of different frame rate. One is 30, the other is 30.888 or something. I'll show you later. I can like change the code a bit. Switch animation I showed you. So to I'm gonna change the choreograph for the fighting choreograph and change the frame rate a little bit just to show that the speed can change. So you can see immediately this human is moving much slower and it doesn't really match up with this guy over here. It's still in the pre-punch mode. Revert it to 30 frames per second. Okay, so skeleton it all loads from the model file. We just converted the teddy. We're gonna initiate the skeleton and the model, we don't care. And the animations we load up from the same files. We're gonna use the eat function to load each clips into the memory, our buffers or whatever we call it, and we give it a name for each clip. Same goes for the humanoid. And so basically, how I set up the scene for the animation to work is that I have actors. So what the actors gonna serve us is this acts like the puppet master, which control a skeleton. So whenever the scene load up, we have a skeleton, and each actors play separately, and one for each humans. And the actor is gonna ask for the skeleton, and the skeleton is gonna create a duplicate of that skeleton's skeleton hierarchy, to be exact. It doesn't. Haven't really incorporated the reference model for the time being. So skeleton is basically just parent-child relationship. That's it. And animations, the actor stores the information on skeleton and a reference to the animation as well. So when the actor is updating, it will query the animations. Oh wait, no. What I mean is we create animation components, and animation component is gonna deal with animations, not actor dealing with animations. So actor dealing with the animator controller, and the animator controller has all the frame rate stuff in there, and animator controller is gonna query the frame data. It's gonna fetch the position, orientation, style, scale based on the frame calculations, and it's gonna store the it's gonna change that quaternion here. Actors fetching all the quaternion and the rotation translation stuff, and stored in each of the bones, which it iterates through this linear array here. Well, it's not exactly a linear. It's, oh yeah, it is. For this case, it's linear. And then for each bones to properly translate, so what the actor does is store the animation matrix in a buffer, and when the buffer updates, it follows the tree hierarchy. The game object bone is actually the PCS tree. It follows the PCS tree structures, and the parents updates first, and then the child updates. So yeah, this is for if we incorporate the reference model, but right now we don't. So just modify the parents matrix and add it to the animations buffer matrix, which is composed from the actor. And yeah, that's pretty much the overall structure.